Welcome, everyone. Thank you so much for joining. We are going to start with today's session. And as you all know, this is the Devops Bootcamp. So let me just quickly share my screen. Arnav, can everyone see my screen?
Yeah.
Okay, great. Let me first walk you through the agenda for the day, for actually the 2 days. So the agenda for 2 days is we are going to start with what is DevOps, and then we are going to talk about why we use DevOps and how it is useful to us. Then we are going to talk about the stages of DevOps, and broadly the stages are source code management, continuous integration, configuration management, continuous logging and monitoring, and continuous deployment. So these are the stages of DevOps that we are going to cover today and tomorrow. So that's the agenda. Now I'm going to get started with the main content right now. So let me start by why we actually use DevOps and what DevOps is. So the earlier, when there was no DevOps, there was something called the waterfall model of software development. So waterfall model is the earliest software development lifecycle model that was used in software engineering. And what do we mean by software development lifecycle model? So software development lifecycle is nothing but the process through which we design software, and waterfall was the earliest of that. So the waterfall model, just like a waterfall in real life, falls from top to bottom and is sequential. This model was also sequential, and in uh, each phase of this model, it was like the earlier phase has to be completed before the next phase could be started. So the steps in this model are requirement gathering, where you basically gather requirements and analyze from the customers. The second step is designing, where you design your software architecture. The third step is implementation, where you code and implement your software. Then the fourth step is testing, where you test your software, and then you have deployment. And after deployment, your software product is ready, and you basically maintain it. So this seems like a pretty simple and solid model, but this model has a lot of disadvantages. So let's get into the disadvantages. So let's say you have gathered requirements, and you go through the rest of the process, like designing, implementation, testing. And then when you're in the testing phase, your client comes and tells you that our requirements have changed, and you need to include some additional requirement. So what would you do? You would have to go back to the requirement stage and then do all these steps all over again, uh, to incorporate their requirement. And also, like, because each step is very sequential and it only happens when the previous stage completes, uh, very little software is produced until the later stages, and there is no iteration. And this model is especially very difficult for long projects or complex projects. And also, when a lot of people are collaborating, this sort of a model gets very difficult. So that was about the waterfall model. So to solve some of the problems of the waterfall model, something else came up. So next, what came up was the agile methodology. And the English dictionary basically defines agile as someone who is able to move quickly and easily. And this sort of resonates with this method of software development. Let's see what agile is all about. So in Agile, each project is broken down into several iterations, and typically each iteration is of the same duration, 2 to 4 weeks. And then at the end of each iteration, the project is delivered. And in each iteration, a lot of cross-functional teams work together. So as you can see in the diagram, so for example, you have 3 sprints. In the first sprint, you gather the requirements, you design, develop, test, and deploy, and then you show the product. And then the same thing happens over and over again in each string, in each sprint. So now this seems like a great model. So like we should, we don't see any disadvantages of this at the first go, but this also has some limitations, even though it's a good model. So some of the limitations of this model is that there are a lot of conflicts between the development side and the operation side. So the development side of any project is basically the people who are coding the software, and the ops teams are usually the team that is deploying your code and doing the configuration in your production environment and things like that. So imagine a scenario where you have written code and you have told the ops team that, okay, you can deploy my code. And the ops team tries to deploy your code. So you have tested your code in your local environment, which is and maybe your test environment, but the ops team is going to do it on production. And sometimes the computing environment of local and production is not the same, and so the ops team might face an issue and they might encounter a bug. So then they're going to tell the dev team, they're going to come back and tell the dev team that we found some bugs in your code and you need to fix this. So till the time the ops team is finding the bugs, the development team is basically waiting for the ops team to give it feedback. So the feedback loop is very slow over here and a lot of time gets wasted. And if the development team makes any changes, the ops team has to manually deploy and look at all the provisioning scripts, etc. So dev team basically wants agility, development people want to move fast, and ops people want to move stable. Ops people want stability. So this is the sort of conflict that arises in agile. And so to resolve this, the third software development lifecycle methodology came up, which is the DevOps methodology. So it pretty much solves all of the limitations of agile and waterfall that we saw. So let me first off tell that DevOps is not a technology. A lot of people think it is a technology, it is a methodology. So it is the practice of operations and development engineers participating together in the entire SDLC, from design to development to deploying it on production. And if you Google DevOps, you might see that a lot of the DevOps symbols are actually infinity. So infinity symbol suggests continuous process of improving efficiency and constant activity. And in DevOps, the updates are much faster and the teams also develop very quickly. So now that you know what DevOps is, over the next 2 days, I'm going to cover all the 3 stages of DevOps that you can see in this slide. But let me give you a brief overview here. So the first stage is source code management. So in source code management, we are basically going to cover version control, which is maintaining multiple versions of a code base. In continuous integration, we are going to look at what it is and how it allows developers to build products faster and more efficiently. And continuous delivery and continuous deployment, it ensures that we can deploy whenever we want. So these are the things that we are going to cover in more detail over the next 3 hours, 1 hour today, 2 hours today, and next 4 hours, sorry. So before we move on to the next section, I have a small quiz for all of you. Let me just do that. Okay, so I think the quiz has ended. Let me just close this. Arnav, can you uh, help me out here? I see nobody on the leaderboard.
Um, 1 second. Guys, has the quiz ended? Can anyone please share in the
Yeah.
chat? Yeah, it's ended. Okay.
Okay. Um, I think we can figure that out later then. Let me just. Was everyone able to click on the quiz and take part?
I guess people are able to see the quiz leaderboard. We are not able to as of now. Maybe we can sort
Okay.
it out later. Yeah.
Yeah, no worries. That was all about why we use DevOps and how DevOps came into picture. Let's move on to the first stage of DevOps now, which is source code management. Source code management, as the name suggests, is the component of software management, and it is also known as version control, and it helps in the management of changes to documents, computer programs, and large websites. And Git is the most commonly used version control system, and I think a lot of you might have heard about it. So next, we want to look at what is version control and why do we need it. So as I mentioned before, when you are making lots of changes to a program or document or anything, you need version control, which manages those changes. So what version control basically does is every time you make a change, this version control system is going to create a snapshot of it, and it's going to save it, and later on you can go back and look at the changes that you made, and also the versions of your software or your program. So why do we actually need version control? So let's say you and your friends are trying to modify the same file, and your friend has modified it before you modified it. So there might be a lot of conflicts that might occur, and it might get confusing as to who has made what changes. Version control is helpful in such scenarios. And let's say that everyone is pushing code into a repository, there's no version control, and someone has pushed in a bug. So what would be the thing? You would have to go through the entire source code to see where the bug is, when was the bug introduced, and it can get really ugly. But with version control, because there is a history of everything that's happening to your program or your code base, you can basically look at which commit or which line of code is causing the problem, and then you can just roll that back. So you can revert that, and then you can roll back to a previous version where your code was working properly. And another thing is that in version control, generally how that works is there is a central server which has a copy of your source code, and then developers make local copies of it. So this allows for a really good backup system, because let's say the central server crashed. There are 10 or 20 other people who have local copies. So you can use one of their local copies and restart the server or reload the server. So it makes for a great backup, and it of course helps you analyze your project. So next, we are going to talk about version control tools. So there are lots of version control tools in the market, and some of the most commonly used are Git and Mercurial. Git is the more popular one, which we are going to look into more detail today. So next, I want to talk about Git and GitHub. So you can see this diagram on the slide. So before we get into the diagram, let me tell you what GitHub is. So people often confuse Git and GitHub. So Git is basically a version control tool, and GitHub is a platform that allows us to host a central repo, and then we use Git on it. So g- uh, like on GitHub, you can push in your source code, and then you can other people can locally make copies of it and keep working. And another good thing about GitHub or Git is that when you have a copy of someone else's code, you do not need internet for anything except for like pushing your code to the repo or pulling new changes. You can keep working on it without the internet. So let me explain this diagram to you in more detail. So you can see on the first line it says distributed version control system, and just below that there is a server, and that server is the central repository. So let's say that server is the central repository, and it has three copies of it. So repository 1, repository 2, and repository 3. So now what these repositories are doing, they are pushing and pulling from the central repository. All the changes that are happening, they are pulling it to themselves, And if there are any changes that the central repository does not have, they are going to push those changes. And now from these repositories, you can see working copies. So let's say there are three people who have three PCs, workstation 1, workstation 2, and workstation 3. So what they are going to do is they are going to commit their changes to the repository. And if they have, if workstation 2 makes some changes that workstation 1 does not have, it's going to get updated as this repository is going to pull from the central repository. So this is basically what Git and GitHub does. Next, I'm going to walk you through Git and how to make a repository, and explain some practical aspects of it. So let me just share my screen for now. Is my screen visible, Arnav?
Yep, yep.
Okay, great. So I'm not going to go into the details of how to install Git because they have really good documentation. Okay, sorry, I forgot to mention something. So right before I start, there are two ways of going about this bootcamp. The first is you can continue working with me, or and you can try to do it yourself. And the second one, which I suggest, is that you take a look right now, and all these resources will be shared with you later. So later on, you can follow these guides, and you can also follow the steps that I did, and you can create your own thing. So I suggest the second one so that you don't miss anything important while I'm doing all this. So yeah, I'm not going to explain. I'm not going to show you how to install Git because I already have Git installed, and the documentation is very comprehensive. So you can Google install Git, and it will take you to the official documentation of GitHub. And over here, there are. So I am on Mac, and on Mac you can navigate to the latest Mac. You can download the version from this link, and after the installation is complete, you can type git version to verify git was installed. It's just a very simple three-step process. So let's say that git is installed. Now let me just show you how you can check if git is installed. So it says over here, you can do git version to verify if git was installed. So you can see it says git version 2.30.1. So that means I have git installed. Now let me show you how to make a repository on GitHub. So you can go to github.com, and when you are on github.com, you can see recent repositories here, and then you try to create a new repository. So let's uh, name this repository Scalar Bootcamp app. And the description is optional, so I'm just going to leave it blank for now. And then you have two options of creating two options for this repository. You can make it public or you can make it private. So I'm going to make this public so that any one of you can go and see this. And then I'm going to add a README file. So adding a README file is usually a very good practice for GitHub repos. And this README file basically contains information about how to run the project and anything else that you need for this. So I'm also going to add a git ignore. So what is a git ignore? So basically git ignore, as the name suggests, it is a template for some of the files that I don't want to commit to git. So let's say if I choose Python over here. So there are some auto-generated files in Python like PYC files that I don't want in my GitHub repo. And if I just add a git ignore for Python, it takes care of this automatically. And then I need to choose a license. So license is a very common thing in open source projects where you can license your code so that others can use it freely. So I'm just going to give it the MIT license so that anyone can use this code, and then I'm going to create a repository.
Atibhi, one small request from the audience going forward. Maybe you can zoom
Yeah.
into the bits where there's a lot of space on the screen.
Is it better now?
Yeah.
Okay. Thank you for letting me know. So this is the repository that was created right now. And now I'm going to show you how to make changes in this and what exactly happens. So let me first use the UI to make changes. So over here, I have my README file. I'm going to go to my README file and I'm going to make some changes here. Let me write this is a demo Flask application. And what I'm going to do is next, I am going to commit my changes. So what this commit basically means is I am going to put in my changes into this repository. So they have a default commit message, but let me just write this. And I don't want an, and I'm going to commit it directly into the main branch. So let me commit this. So now, if you can see, my readme.md has the updated information. And I also have a history of all the changes that I made. So if I go on this right-hand side and I click over here, you can see that there are two commits. That means there are two changes that I have made to this branch. And let's go to the initial commit. So initial commit was the commit in which I created the repository. So you can see in this commit, a git ignore file was added, and then a readme.md was added, and an MIT license was added. And now let's go to the second change and see what all I changed in the repo. So you can see that it shows showing one changed file with 3 additions and 1 deletion. And you can see that it shows that earlier the readme file just had this line, but in this change I have added one more line. So this is how you can make changes from the UI, but it's more handy to do everything on the terminal. So let me explain that to you as well. So when I go on code over here and when I click on this link, it means that I'm going to use HTTPS to download my repository to my local. So Arnav, is my terminal visible properly?
Yeah, yeah.
Okay, great. So I'm on my desktop right now, and I'm going to do a command which is git clone, and I'm going to copy paste this HTTPS repository. So basically, what git clone does is it clones the repository that I have linked. So
Atibhi, can we zoom in on the terminal
let me zoom in a bit more. Is it better now?
a bit more?
Now?
Yeah, fine now. Thank you.
Okay, no worries. So yeah, I have cloned it, and you can see right now on my desktop, I have another repository called Scalar Bootcamp app. So that's that. And now let's go inside this directory. So now that I'm inside this directory, you can see that I have two files, which is license and readme.md. So now let me do something. I want to make changes to readme.md, but I want to do it in a different branch. So what does that mean? So branching is a way in which you can make copies of the main branch, and a lot of people can work differently on different branches, and when your code looks good, you can merge your branch into the main. So let's say there was a e-commerce site and one person wanted to work on um, the payment system, and they were working on the payment system and they were changing a lot of UI, and then another person also wants to work on the UI, but they do not want to work on the payment system. So if they work on the same branch, it might get very complicated because some dependencies might be there which one person has and the other doesn't. So they just make different branches and they continue working on it. And when they feel that their code is in a ready state, they send a pull request to the main branch and get it merged. So I'm going to explain that in more detail. So now let's make a new branch from main. So git checkout minus v. Let's make a branch called dummy. So now I'm in a dummy branch, and using git branch, I can see my branch's name. So now what I'm going to do is I'm going to make a change in the README file. So let's say this is a demo Flask application, and then let me add um, a new thing for scalar bootcamp, and I'm just going to save it. So now that I have saved this file, you can see the content, that the content of this file is changed right now. But if you go to the central repository on the main branch and you see the readme.md, it still says this is a demo flask application. The changes that I have made in a different branch in my local have not been translated to the central repository. So how can we do that? So I'm going to do a git add dot. So what this basically means is I'm going to add all the files in this folder to the staging. Uh, so staging is nothing but a step between your local and central repository, in which it keeps the files until it's pushed to the central repository. So after I had added, I'm going to make a commit, and I'm going to make a commit added new line in readme. So this commit is going to have the change, and you can see that it says one file change, one insertion, one deletion. And then I'm going to do git push origin and my branch name. So when I do git push origin Atibhi dummy, let's go to my scalar and check repo and check the readme. So even now this readme is not changed, and that is because we are on the main branch. So we need to get the changes from the main branch, from my dummy branch into the main branch. So you can see that it on its own shows a pop-up that this branch had recent pushes. Do you want to compare and make a pull request? So yeah, I do want to compare and make a pull request. And what I'm going to do is I'm going to make a pull request. So a pull request is basically me requesting the owners of this repository that I want to make changes in your code. Can you please review this piece of code that I wrote and merge it if everything looks good? So I have created a pull request. Now you can see over here that my pull request is created. Now I go to my pull request, and because I am the owner of this, I can just merge it. So let me just merge this to master, and it says pull request successfully merged and closed. So let's go back to the code. And now let's look at the README in the main branch. You can see this is a demo flask application for Scalar Bootcamp. So it has pulled in all the changes from the Atibhi A.dummy branch. Now let me show you something else. Now that you have all the changes in main in your central repo, you need to get these changes in your local as well. So we are on the dummy branch. Let's go to our main branch. And now when I do, you can see that over here, the text has not changed. And this is because we haven't pulled in the changes from uh, the central repository yet. So what I'm going to do is I'm going to pull in the changes, and over here you can see it says one file changed, one insertion, one deletion. And now when I do a cat readme.md, it's going to say this is a demo flask application for Scalar Bootcamp. And that's the whole cycle of how you can use source code management to make your life easier. So I'm going to stop here and see if anyone has any questions till now, and also have like a small quiz. Okay, so I got the feedback that uh, it's very fast. Thank you for the feedback. I'm going to go slow so that the rest of the sessions are clear. Is there anything you all want me to repeat? Okay, so some people are saying Some people are saying speed is okay. Some people are saying speed is slow. Okay, so I think a lot of people are confused in what is Git branching. So I should maybe explain that in more detail. Let me look at the chat. Okay, so let me just explain what Git branching basically is. So when we talk about branches in Git, so like I said, there is a main branch which is created when you create your repository in Git. And now let's say that people want to start working on different features. So branching is a feature that's available in version control. And in Git branches, you can start working on different features at the same time. So when you want to add a new feature or fix a bug, like however big or small is, you make a new branch for your changes. And then you, after making the branch for your changes, you send a request to the main branch so that your code can be merged. So this makes it really hard for unstable code to get merged into the main code base, because not everyone will have rights to the main code base. And it also gives you the chance to clean up your code based on the reviews from the folks. So that's about it. Are there any more questions? So there's a question, who is going to merge the code? So merging of the code is basically done by the people who have access to the code base. So if I am the creator of a repository and I have access, I'm going to merge the code. How can I see my commits? So when you go to GitHub, you can click on that clock icon at the top right to see your commits. Or if you are on your local, you can use a command called git log, log, to see your commits. Yeah, I'm not sharing my screen right now. I'm just looking at the changes. Yeah, so code merge is often manual because your code needs review, and that review is always manual. Can we create Okay, so a lot of people are asking what is Git cherry pick. So basically, what cherry pick is going to help you do is, let's say you have commits 1, 2, 3 on a branch, and you want commit 2 in a different branch. That branch doesn't have these commits. So what that branch is going to do is, you can use git cherry pick to pick up the changes of one commit and take it in your different branch. So that's what git cherry pick does. um, so there's a lot of questions around merge conflict. So let me tell you what merge conflict happens is. So let's say two people are changing a same file, and they have, one person has pushed in some changes and the other person doesn't pull those changes beforehand. And even if they pull the changes, there are some lines which are conflicting. So then they will get merge conflicts, and then they will have to resolve it. Okay. Okay, so I think most of the questions that were relevant have been resolved. So I'm going to move into the next part, and let me going to share. I'm going to share my screen for this part. Can all of you see my screen? Arnav, is my screen visible?
Yeah.
Okay, so next we are going to work on a sample Flask application, and we are going to make the sample application so that later on when we are doing continuous integration and continuous deployment, it's easier to understand things. So let's see what Flask is. So Flask is basically a web framework written in Python. So you can use Flask to make web apps, and I'm going to walk you through the installation of Flask and also the quick start guide. So documentation is really good for Flask. It's pretty simple and good. So if you can see over here for installation, it tells you basically what all you need to install, and after you have them installed it tells you to create a project folder and a virtual environment within it. So what exactly is a virtual environment? So a virtual environment is a tool that helps you to keep dependencies required by different projects separate by creating isolated Python virtual environments. So that's the technical definition, but virtual environment is basically something which is very important for Python developer. So you can think of virtual environment as isolated environments in which all the libraries that you need will be installed, and each virtual environment is separate from one another. So let's say virtual environment one has some dependencies that you don't need in a different virtual environment. So you will just not install them in that virtual environment. So right now, let's get started with creating a Flask application. So you can see I'm on my main branch. I'm going to do things on the main branch from now on. So this command over here, Python 3 minus m venv, it allows us to create a virtual environment with the name venv. So I'm going to do that. So you can see that a folder venv has been created. Now, what I need to do is I need to activate this virtual environment. So there's a command over here again, which says you need to activate the virtual environment. So let me activate it. So as soon as I activate it, you can see that there is a venv in the bracket over here. So this is a symbol that the virtual environment has been activated. So now basically what will happen is if I install anything in this virtual environment, it is going to be usable only in this environment. I won't be able to use it from outside the environment, and also like nothing will get installed on my uh, global environment in my local machine. So after we do this, let's install Flask. So Flask is getting installed. So meanwhile, let's go to the quick start, and I also have like a demo application ready where I can probably start explaining things. So okay, so we have Flask ready, and now what I'm going to do is I'm going to open this in Visual Studio. Visual Studio is a text editor, and I'm going to open a new folder. Okay, so you can see that I have opened this in Visual Studio. Now I am going to create the Flask application. So let's go to the quick start guide beforehand. And
Actually, just one small request on
yeah,
the ID, right? If you can
yeah,
focus a bit.
yeah. Is it better now?
Yeah.
Okay. So yeah, let's get started with creating a Flask application. So well, let me close this tab as well and this tab as well. Okay, so this is how a minimal Flask application looks like. So let me just copy paste my version of it. So I'm going to explain it to you in detail what it does. So over here you can see that the first line, it says import from Flask, import Flask. So if we go to the documentation, you can see that first we have imported the Flask class, and then we create an instance of this class. So basically what this does is this tells us that we have created a Flask application with whose name is app. Then we have the line app.route and then a slash. So this route decorator, it is going to tell Flask what URL should trigger our function. And then the function returns the message that we want to display in our browser. So that's about it. And now how we are going to run it. Let me go to the terminal. So we have our app.py here. I can do just Python app.py. And you can see that it is saying that it is a development server, and it's running on local on port 5000. So let's go to port 5000. And when you go to this port, you can see this hello world, which is what our Python, what we were trying to do. So now that we have a basic Flask app running, we want to commit this to GitHub. And I have closed my server, so now this page should be down. Okay, so now we are going to commit it to GitHub, and like before, I'm going to do git add. So okay, so I have added it to GitHub right now, and this is like we are going to use git again and again. So you should be able to. So over here, you can see that just 17 seconds ago, I added an app.py. So this is the basic Flask app that we are going to use for the whole of our course. And just over here, I'm going to pause and stop sharing my screen and look at any questions if folks have any questions. So the screen is not stuck. I have just stopped sharing my screen so that it doesn't, the experience is good for you guys. So I think people are asking about the Flask function. Okay, I can cover that again. And okay, so one person wants to know what is VENV, and the other person wants to know what is a Flask application. So VENV is a virtual environment. So what is a virtual environment? Like I said before, it's a tool that helps you keep dependencies that are required in different projects separate from each other. And it does so by creating isolated Python virtual environments. And what the VENV in my terminal was that I had created a virtual environment whose name was VENV, and I had activated it. So that's what VENV is. And another person wanted to know what is Flask. So Flask is nothing but a web framework of the Python language. So web framework basically means it allows you to create web applications with ease. I hope that has. So virtual environment is not the same as a container like Docker. I'm going to explain Docker and containers later on. So which step are we covering right now? So right now we are not on any step. We have covered the first step, which was source code management. And right now we are just building a simple Flask application. Yes, V is for Python related project. So you cannot use Flask with Java. Flask is a different framework. Yes, like he's saying, for Java there are Spring frameworks. Okay, so I think I have covered all the questions that um, people had. So let me just quickly recap what we covered before the break. So before the break, we talked about what is DevOps, and then we talked about source code management and Git. And then we were going through how to build a simple Flask application, and we had gotten like a basic Flask application ready. So just before we move on to continuous integration, I want to show you by writing a small test for our Flask application. And it might not be very clear now why we are doing that, but it will definitely become clear towards the end. So let me share my screen. Arnav, is my screen visible?
Yeah, Atibhi, before that, I think very quickly we
Mhm.
had to release a poll for people. I think
Okay.
since we okay, guys, I hope you were able to fill out the poll for Scalar Academy interest. Yeah. Okay, okay, okay. Cool. I guess we did that. We did that with Jatin. Cool, cool. Atibhi, you can take over. Yeah.
Okay, great. So we basically wrote a Flask app that shows you "Hello World" on a port, and now we're going to write a test for it. So I have copy pasted the test from beforehand. Let me just explain what this test does. So it imports the app from the app.py, and it creates a client for the server, and it gets the data from the server, and it sends a request and it gets a response. So then what lines 4 and 5 do, they are the core part. The lines 4 and 5, they say that the data that you got in the response, it is hello world. So it should be hello world, because in app.py we are saying that this path returns hello world. And then on line 5, we say that the status code is 200. So by status code, we mean that, for a web page, there are different status codes. So if a web page is not defined, it's 404. And if everything is okay, it's 200, which says the web page is healthy and working. And there are other status codes like 302. That is like beyond the scope of this. You can check it out later on. So now that we have test app.py, uh, let's run that. So yeah, it was successful. There was no error over here, but let me show you a failing test and how that looks like. So let's say we remove this and we expect the data to be hello world, but in the server we have done hello world exclamation mark. Now, when we run this test, what happens? It gives us an error. And the error is that in this line, assert response.data is equal to hello world. It says it is not equal. So this line is not going to work. So let me just change it right back. And now we have a working test. So let me just quickly add this to GitHub. Okay, so now we have added our test. And now we are done with the Flask application part. And now we are going to move into the continuous integration and deployment portion. So just before that, I want to share my screen again. Give me a moment. Okay. Uh, Arnav, is my screen visible properly?
Yeah.
Okay, great. So let's now talk about continuous integration and deployment. So, uh, it's very important for any company to have a great developer workflow, and a great developer workflow makes engineers more productive, and a bad developer workflow makes them more frustrated. So, CI and CD, continuous integration and deployment, are two best practices that have become super popular over the last few years. So, what is continuous integration? Continuous integration is nothing but the practice of testing each change done to your code base automatically and as early as possible. And continuous deployment follows the testing that happens during the continuous integration and pushes changes to a production or staging environment. And it makes sure that a version of your code is accessible at all times. We're going to look
ये
into all this into
ये भी
more
पट्टी
detail in the
सुनाइए ना।
upcoming slides. So this slide basically shows you some of the
नहीं,
tools
मैं
that are used for
लगा के बाद ही
CI/CD.
जाऊंगा।
Some of the popular ones are Jenkins, Circle
हम्म।
CI, Travis CI, CodeShip, Urban Code.
खड़े
And
के रहूंगा।
today we are going to
खड़े
use
के
GitHub
रहूंगा, उससे बोलूंगा
Actions,
जो
about which I'll talk in
उससे
more detail
बोलूंगा
later
जिसपे
on.
सबसे ज्यादा
But
मक्खी
before
खुल रही है वो
that,
थे
through this diagram,
सड़ेंगे।
I want to explain the whole flow of continuous integration. That's our focus right now. So before the world of continuous integration, what would happen? So there were a group of developers and they would make um, randomly commits to the source code repo. And when they are making commits to when the entire code is in the repo, it will be built. And if there are bugs, the devs will be informed. So the devs had to wait for a long time to get the test results. And after they got the test results, they had to go through the entire code to find the bug and fix the bug. This reduced their software delivery process. But in CI, what happens is developer commits changes to a repository, and after every commit, a build is triggered. And when the build is triggered, then automatically our CI pipeline builds our code, tests it, and deploys it to the test server. And if the tests show a bug in the code, then the developers have to check only the last commit that was made. They don't have to check the entire source code. So as soon as there is a bug introduced, the CI pipeline is going to warn you that there's a bug and it's going to fail. Sort of similar to how I ran the test and showed you that the test had failed. And then you can quickly figure out what's the problem and fix it. And so an event, typically a change in the source code repository, triggers the CI pipeline. And the CI pipeline has many stages. So one of the stages is the build stage, and it is the stage in which the code is compiled. And then after the build stage, there is the test stage. So this test stage is where the code is tested. So, for example, we are developing a Flask application. So, what our continuous integration server will do is it will pack all our files along with the application and build our code. And after our build is successful, it's going to run the unit test that we wrote, the simple unit test. And if the test is passing, the pipeline is going to say, okay, your code looks good and it can be merged to the main branch. So CI reduces testing costs and it reduces the chance of bugs getting shipped to production, and it also improves developer productivity. And some of the things that you can add on to your continuous integration pipeline are tools that enable consistent coding style, and you can also notify developers of the build stage outcome. So in your CI pipeline, for example, if your build is successful, you can notify the developers. And yeah, you can also have some checks for security vulnerabilities in your code, and your CI pipeline can warn you that there are some vulnerabilities. And apart from this, in your testing stage, you can parallelize your test, so that your tests are faster. And you can also have tests for security, and only if these security tests pass, you can move on to the next step. So that's all about continuous integration. Um, Next, we are going to move into a continuous integration, how to enable that for our repository, and we are going to use GitHub Actions. But just before we move on to that, I want to check if there are any questions. Okay. So I can just see thumbs ups. I don't see any questions. So no, continuous integration doesn't mean building and packaging only. It is build and test and release. So what about integration tests? Integration tests are also a part of testing portion in continuous integration. Yeah, you can use Jenkins for CI. You can use Travis CI. There are many things. So someone is saying explain what are artifacts. So we are going to explain that later, tomorrow onwards. Yeah, we are going to work on Docker later on. GitHub Actions is not the same as Jenkins, but it is a means of having CI in your pipeline. Okay, so let me just walk you through this. So now that we have our test.testapp.py ready, I'm going to do something. I am going to do. I'm going to explain this this thing just in 1 second. So basically, what I did, pip freeze requirements.txt. I freezed my virtual environment and I put all the dependencies into requirements.txt. So requirements.txt has all the dependencies that I need for my Flask application. So cat is a command which helps us to see what is inside the file. Let's do this. So you can see that these are the dependencies that are there in the requirements.txt. So this is auto-generated, but we can modify it. So for now, I'm just going to keep Flask. I don't really need all this right now. And then I'm going to push this to my GitHub repo. Okay. So now,
Atibhi, so sorry to
yeah,
jump
yeah.
in. Are you sharing something? All I can see is the GitHub Actions screen right now.
Oh, okay. Let me share my screen. Yeah. So let me just repeat what I did. I did a command which says pip freeze requirements.txt. What this does is it freezes the virtual environment and puts all the dependencies in a file called requirements.txt. And then I see the contents of requirements.txt. These are the requirements that are needed. These are so Flask was the thing that I installed in my virtual environment, and all these things, Flask has dependency on them. And then I just committed and pushed my requirements.txt to GitHub. So that's what I did till now. Next, let's move on to the slides. So now we are going to talk about GitHub Actions and what GitHub Actions basically is. So just a second. So basically, GitHub Actions is a tool that helps you organize your developer workflow. And so, for example, you are running an organization, and every time you merge code, you want to do a few things. You have a checklist, let's say, and that checklist could be that after you have a release, you have some release notes, or you want to validate something after you have merged the code, or you want to deploy something. So GitHub Actions helps us to automate these workflows. It basically allows you to automate all these checklists, and you don't have to manually do that. And it allows us to create a CI/CD pipeline. So how this works is when something happens to or in your repository, the actions are executed in response. And it is basically GitHub Actions is listening to the event, and if the event that you want happens, it triggers a workflow. And this GitHub Actions is actually managed by GitHub, and every build for this GitHub action happens in a fresh virtual machine. So that's about GitHub Actions. Now we are going to actually see in practice what happens. Let me just close all this. So let's go to the bootcamp part. And now you can see that we have all these things here and we have all these files here. And if you look at the commits, you can see there are various commits. Now what we are going to do is we are going to go to the actions portion and we are going to set up a workflow ourselves. So let's name this main.yml. And you can see there are many things here, but I already have something prepared from before. So I'm just going to copy paste the parts of that. Don't worry, I'm going to like explain everything in detail. Okay, so let me just explain all these things to you. Let me remove this. Okay, so basically what we do is we name this workflow CI, continuous integration, and we want this CI to run only on the main branch and not on any other branch. And like I told you before, each build is built in a fresh VM. So for our virtual machine, we want an Ubuntu virtual machine. So I have written here Ubuntu latest. And after this, what happens is it checks out our repository. So that's what this does. And then it sets up a Python environment in our virtual machine. So this is the command for setting up a virtual Python environment. Now next it installs the dependencies. So this is where the build stage comes up, where it installs the dependencies and builds our code. So remember the requirements.txt file that we had generated, it has the list of dependencies in it. What we can do is we can just read that file and install all the dependencies from that file itself. So then it runs two commands, which is it installs pip. Pip is the tool that is commonly used in Python. And then we do pip install -r requirements.txt. So line number 25, what this basically does is it installs all the dependencies from this file. And lastly, we run unit tests. So I had written that test app.py file. So only if this is successful, our CI pipeline is going to be successful. So in the end, we run this. Now I'm going to start this commit. And now when I go to actions, you can see that for this commit, the build has started. Now let's click on this build. The job is starting.
ये भी देखना है कुछ
I don't know why this is not running as of now. Let me cancel this workflow and run it again. Yeah, so I guess there was some problem. So now you can see it is running, and these are the steps that I had defined in my CI pipeline. So first it is setting up a job, and you can see that the operating system is Ubuntu, which is what we had specified in our line over here, runs on Ubuntu latest. And then you can see that I have given, like these permissions are there by default. And then it checks out our GitHub repo. So you can see that it runs the action and it syncs the virtual machine to this repo. And then it initializes the repository. And yeah, so it basically syncs it. And then it sets up Python 3.6. So you can see that the Python version is 3.6. Then it installs the dependencies. So you can see that the first command is run this thing, but it says that the pip was already installed, so this was not really required. And then what it does is it runs the second command, pip install -r requirements.txt. So you can see that it starts collecting Flask and all the dependencies that Flask has. Then you can see that it runs the unit test. So it runs python test app.py, and that is successful. That's why there is a tick here. And after doing that, it just runs a post action. It cleans up whatever things we don't need, and then the job is complete. And because this build is successful, you can see a tick mark over here. Now that's about how you set up a CI pipeline. Let me quickly show you an example of something. So let's again create a new branch. So we have created a new branch, and now what I'm going to do is, um, let me just do, okay, so I have just changed the text over here, and now let's add this, commit it, and then push it. Okay, so I need to pull it beforehand. So as you can see, this is a good example of why we need to pull from the remote repository. So the central repository on GitHub, it contains the workflow files which are not there in my local. So it's so this error says that I do not have those changes, and that's why I cannot update it, because if I update it, the central repository will get confused that did I delete those files, or were those files not even there. So I need to first pull it. And then after I have pulled it, you can see that it says merge made by the recursive strategy, and this GitHub workflows main.yml that was added to this branch. So now if I do git log, you can see that after this commit, this is there. Anyways, now we are going to push our code. And after we have pushed our code, one second. Okay, I have made the changes in the main branch itself. I forgot that. So in the main branch, you can see that, I think I have made some mistake. One second. Okay, I was on a different branch. I actually need to go to my main branch again. Okay, and now when I do git log, yeah, the last commit is that I have added requirements.txt. Now I need to pull the original main branch so that I have the workflows file. And if I see over here, so if I see over here, I have created a main.yml file, but I cannot see a main.yml file over here. So let me just go back to my demo repo and show you how it looks like. So basically what it should look like is there should be a .github/workflows folder in which we have a main.yml file, And this main.yml file should contain all the details. Now I'm not sure why it's not showing up here. Hmm. Let me just. Okay, never mind. So what I'm going to do right now is, in the interest of time, I'm just going to copy paste my workflows file from here itself. Wait, I don't have that here also. Okay, so never mind. I don't know what's happening. I think it's going to take me a while to figure out why I'm not getting this file over here. But meanwhile, I can take some questions. So let me just stop here and see if there are any questions. So are there any questions? So people are saying that they want to go to the. Okay, so let me just see if there are any questions right now. Okay, so there are no questions. Let me just see what the next slide is. So the next slide is Docker. So just give me 2 minutes to figure out what basically happened over here. I am on which branch? Let me just check that. I'm on the main branch and there is requirements.txt. So this looks fine. Now let's go to the Scalar Bootcamp app. And over here, everything looks fine. I need to go to the actions and I need to, let me create a new workflow. And if I set up a workflow, so it says this, I'm not sure if I committed this or not, but let's check again. And then, okay, and then what do I do? I commit it. So I think I forgot to commit it the last time. Okay, so I think I forgot to commit it the last time. Now we have the create main.yml over here. And now we can see that, yeah, now we have it. I think I just forgot to commit it. I just started the commit and did not commit it. So apologies for that. Now, if we see, our last commit over here is requirements.txt. But on GitHub, our last commit is create main.yml. And if we go over here, we can see a tick here which says this was fine. Now what we are going to do is git pull origin main. And now you can see that it's correct. It has created the main.yml file. So that's okay. So after this, what I was initially trying to show you was that I create a new branch. Let's say dummy CI, and I go to this dummy CI branch. And now what I do is I change stuff. So I make this hello scalar, and then I make this hello scalar. And what I do is I do a git status to see if the files have been modified. They have been modified. And then I do a git add, and then I do a git commit -m, change world to scalar. And then let me check my branch. I'm on dummy CI branch, so I push it to this branch. Okay, so now that I have pushed it to this branch, I want you to show what happens when I create a pull request. So let's go ahead and create a pull request right now. So, okay, you can see that the changes are there. Now let me create a pull request. Now that I have created a pull request, I can merge it. And as soon as I merge it, the CI pipeline gets triggered, and you can see this yellow thing here. And when I view the details, it is saying starting job. And after it starts jobs, it starts running the CI pipeline, and it runs all the dependencies and the unit tests, and then it does the post job cleanup. So this flow is basically what I meant on this slide, that we commit changes to the repository, and then that repository, when the changes are committed, it triggers our CI pipeline, and then the CI server runs the tests and makes sure that the build is correct. So that's that for the workflow file. And the next topic is Docker. We are just going to cover a little bit of theory about Docker today and see the practical aspects tomorrow. But before going into it, I'll just give 5 minutes for Q&A if folks have any questions. Mm, yeah, so let me look at the questions 1 second. Okay, so I see there are some questions that are there from before. So one question with a lot of votes is, please suggest some good open source DevOps projects to continue this after the bootcamp at the end of this session. A project which is easy to begin with but rich in tool stack. So you can search for Cloud Native Computing Foundation, and when you search for, I'm just stopping screen share for a while. So yeah, you can search for Cloud Native Computing Foundation, and you can contribute to their projects. They also have great mentorship programs for beginners. Then the next question with a lot of votes is, what level of Linux is required for DevOps? So I would say basic Linux should be okay. You should have a basic knowledge of Linux and how it works. And you can always Google some of the commands as you go. The next question that I have is, I'm working in support. Can I switch to DevOps? I think yes, you can definitely switch to DevOps if you study about it. Um, then Okay, so I think I have covered pretty much the relevant questions, and in the last few minutes, I'm going to um, cover a little bit about Docker. So Docker is a buzzword that all of us keep hearing, and it has become very popular nowadays. So let's understand today what Docker basically is. So this might have happened a lot of times, that you send your friend your code and then they say your code is not working, but then you come back with, it's working in my machine. So that's something that we have encountered every day. So there are a lot of different configurations and in the computing environment for dev, test, and production. And an app might work for one developer locally, but for the same developer, it might not work in the production environment. And this was actually a very common problem uh, before Docker came in. So like I said, we're going to deep dive into Docker tomorrow, but before we dive into Docker, I want to talk about microservices, because I think this is very important to actually understand the use of Docker and how that's going to help us. So, what are microservices? So, basically, if you have a very large application, so let's pick up the example of an e-commerce site. So, that e-commerce site has lots of different functionalities. Like we have a payment service, then we have a cart where you add your products. Then you might have a notification service, and then you might have a search bar. So there are so many things that are there. So you want people to work on all these simultaneously. And so one thing that you can do is break down your large application into smaller pieces that work together. And then each component can be developed separately. So this is what microservices are called, breaking down a large service into microservices, small services. So most developers want to keep their applications separate from each other so that they do not interfere in each other's operations. And before Docker, what happened was, let's say you wanted to break down this e-commerce site into 5 microservices. You would need 5 virtual machines for that, and virtual machines are not at all lightweight. So each virtual machine would need to have separate dependencies or like common dependencies for everything, and it became like really highly inefficient and non-practical. So you might not see this with like 5 and 5 examples, like the 5 example, but let's say you have like a Facebook or a Google and you have thousands of microservices running within them. You will need thousands of virtual machines, which would require lots of computing power. It would increase the costs, and it would be highly inefficient. So that's when the container comes in, and Docker is a type of container needs to run, including code, runtime, system tools, and libraries. And if you want to Dockerize your application, you would need to write a Docker file. So we are going to write a Docker file later on in this session, but let me briefly tell you what a Docker file is. So Docker file is a text document that contains all the commands that you would type on the command line to assemble a Docker image. Now, the next question is assemble a Docker image. What is a Docker image? So a Docker image is a static read-only template that contains instructions for creating a container that can be run anywhere. And so you have a Docker file, which is a text document that contains all the commands. You build it and it assembles a Docker image. And that Docker image is a read-only template that contains the set of instructions that can be run anywhere. It's a convenient way to package applications. So then we use this command called docker run to launch a container. And each container that we launch is an instance of an image. So what I mean by that is, like, let's say we have a Docker image for our Flask application. We can have multiple containers for it. Like we can have a container that runs it on port 8000. We can,
Atibhi, sorry to interrupt.
yeah,
Do you think the slides have frozen? I can see the Docker file, build, Docker image, run, Docker container slide right now. Is that the slide you're on?
yeah, that's the slide I'm on.
Okay, guys, it's all right. Sorry, Atibhi. Please go.
Okay. Okay, no worries. So, where was I? So, I was telling that we can have multiple Docker containers for a Docker image. And for our Flask application, we can have a Docker image, and then we can run multiple containers. So, we can have a container that runs our application on port 5000, 8000, etc. Now, yeah, so now the next thing that I want to talk about is a Docker registry, and we are going to look at a Docker registry later on. So Docker registry is just something like a Git repository for Docker images, or like you can say a central repository that contains public as well as private Docker images. So if you Google Docker Hub, you can see that it has many repositories, and you can pull any image and you can run that Docker image, and you can also upload your own image to Docker Hub. So that's for this slide. Um, so the next slide, in this slide, you can see this diagram, which basically shows what we are going to orchestrate today. So we have a Docker file, and we are going to push that Docker file into our Git repo. And then we are going to incorporate that into our CI server. And that CI server is going to push our Docker image into Docker Hub. And after that, what's going to happen is after pushing it into Docker Hub, it can just like we can just pull that image from Docker Hub and run our Docker image. So the next is the demo. Let me just stop sharing my screen for a minute and then share the whole screen. So before I go into the demo, I would want to check if folks have understood what is Docker till now. Let me just look at the Q&A. Um, So what are the compatibility requirements for Docker? Do we need to have the same operating system and processor family across development and production servers? No, so that's the good part about Docker. You just need Docker installed, and whatever computing environment you have, it's going to be separate from your computing environment, and it's going to work. Containers may be stored on virtual machine. Yes, so containers can be run on a computing environment or a virtual machine. Um, Okay, what's the difference between contents of Docker file and Docker image? So Docker file is basically a text file where you write instructions, and then the Docker image is created from it. Uh, okay, so I see that people have understood what Docker is. I see a lot of yeses. So let's move on to the Docker image, to the demo part for now. So Devrup, is my screen visible?
Yes, it is. It is.
Okay, so I'm going to walk through some things, but I'm not going to install Docker right now. I have that installed from before due to time constraint. So if you go on this link, you can just Google install Docker. You will go to the official documentation of Docker, and then you just install whatever Docker you need. And yeah, that's pretty much it. And you should be done for Docker. So after this, we are going to write our own Docker file, and after writing our own Docker file, we are going to. Okay, so let's first start writing a Docker file. So I've written a Docker file from before, so that we can save some time. But let me just explain the Docker file to you. So what I did was, there is this repo, Scalar Practice Demo, and over here I have um, created a Docker file. So there is no extension; it's just Docker file with a capital D. And in this Docker file,
Why to lost
I
one
have
minute?
written
Yeah.
instructions on how to run a Flask app. So what do? I do from Python 3.6
Hmm.
Alpine. So what line 1 means is that it pulls the Python 3.6 Alpine image and operating system, and it installs Python, like all the dependencies. Then what do? I say work directory slash app, and what it does is it creates a working directory for me called slash app, and then I do a copy dot dot. So what this copy dot dot does is it copies all the files in my current directory to the Docker image, and then I do copy requirements.txt. So I copy the requirements.txt file from my current directory to the Docker image. So in case a few of you have missed what a requirements.txt is, let me go back and show you what a requirements.txt is. So requirements.txt is a file that can be automatically generated, and it just has Flask in it for now. So this is the dependency that we need for our Flask app. So after getting copying the requirements.txt, what do? I run a command pip install -r requirements.txt, which installs all the dependencies that are mentioned in the requirements.txt file. And then I do entry point Python and cmd app.py. So this is equivalent to doing Python space app.py on my terminal. So this is how the Docker file is created. Now, what we are going to do is we are going to run our we are going to use our workflows to deploy this on Docker
The
Hub.
container.
So after the Docker file is written, um, let me just show you how we can write it, like how we can use that on actions. But before that, let me just show you what Docker Hub is. So I Google Docker Hub and then I go to this. So you can see that in Docker Hub, there are many repositories. And if I click on explore, you can see that there is an official repository of Ubuntu. There is a repository of Postgres, Redis. So if you, this is the Alpine Linux thing that I pulled right now, and like Mongo, Python. So these are just some things, Docker images that you can pull. You don't have to go through a cumbersome installation process. You can just pull this Docker image to get started. So let's go back to my. So this is a repository that I had created beforehand for this project, and this is the A Square demo app repository. How can you create a new repository? Let me even show you that. So you can click on create repository and you can write the name here, description here. So let's write something. And I created a public repository. So now whatever images I push, it can be seen here. But again, for time purposes, I have created a repository. So we are going to use that. Okay, so we have gone through a Docker registry and a Docker file. Now let's go to GitHub Actions and work on our pipeline to create this. So once you go to Actions, what you can do is you can, let me show you something else as well. You can do GitHub Actions and you can uh, Docker build. So what you can see is the official documentation of GitHub Actions. They tell you how to create a Docker container in action. And over here, they actually show you how to create a Docker file, which is very similar to what we did. And then they also show you how you can create a Docker container. So you can just Google this and figure this out. But I have already created the workflow file. Let me go to my workflow file and explain it. 1 second.
Okay.
So again, in case someone missed yesterday's session, let me briefly explain what a workflow file is. So a workflow file is a file for GitHub Actions in which I have mentioned steps and in which I have mentioned a job and steps that does these steps, which is our CI pipeline. So the steps that we had covered yesterday was setting up Python. This sets up Python in our CI pipeline. Install the dependencies. This installs the dependencies from our requirements.txt. And yesterday we had run a unit test. So today we are going to look at lines 32 to 39. So lines 32 to 39, what they do is they build the Docker image and push it to Docker Hub. And the registry, so let me go through each line. Line 32 is the description. It builds the Docker image and pushes it to Docker Hub. It uses this default Docker build push um, flow. This I copied from the official documentation of GitHub Actions with image. So my image is a square 14/demo app and tags latest. So what is tags? Tags is a way to identify uniquely a Docker container, a Docker image. So I just have the latest tag for my Docker image. If you do not give this, there will be a default tag for it. And then a registry. So my registry is docker.io, which is Docker Hub. There are many Docker registries like AWS Docker Registry, Microsoft, etc. But Docker Hub is the most popular. And then we have the credentials for username and password. So now when you look at this username and password, you might be seeing and thinking that, like it's not written here. So it's not a good practice to commit your username and Docker password to your GitHub repo. So there's a way of doing that. So this Docker username, which you see in capital, this is a config variable which is directly picked up from GitHub. So now we are going to look at how we can add uh, this username and password. So if you go on settings on GitHub, and then you go on secrets, and then you go on actions, you can see that I have already added my Docker password and Docker username here. If I click on a new repository secret, you can just add the name and the value over here. So that's about it. Now let's make a change to our one of our files and see it in action. Before that, let's look at this demo app in Docker Hub, and you can see that the last push that was done, just a second, it's refreshing. So you can see that the last push that was done, it was 2 days ago. This is going to change as soon as we make any changes. So let's just change the README for now. I just changed the README, and let me commit my changes. So now let me go to actions, and you can see that my CI has been triggered, and now it's going to go through all these steps. So let's look at these steps in detail. So again, let me explain everything very quickly. It has set up the job. After setting up the job, it checked out my GitHub repo. Then it set up Python 3.6 for my Flask application. Then it installed the dependencies from the requirements.txt file. Then it ran the unit tests. And then it built the Docker image and pushed it to Docker Hub. Now let's look at this stage. So it says Docker image name created. And so you can see in our Docker file, we had 7 steps. Let me go back to the Docker file and show you the 7 steps. So it had 7 steps in this Docker file. And over here, if you can see, it executes all these 7 steps one by one. So the first step is it pulls the lightweight Linux Alpine and pulling from library Python, and it pulls it. Then in step 2, it goes into this working directory, it copies this, it copies the requirements.txt, it installs the requirements.txt, and over here you can see that you had seen that the requirements.txt had Flask. So it collects Flask, and then the rest of this is just dependencies of Flask. And then it does an entry point Python and cmd app.py. So it basically runs a Flask application, and after doing that, you can see over here it says pushed. So it basically pushes our image to Docker Hub, and then it cleans up the job. So now let's go to Docker Hub and refresh this page. So you can see that the latest build right now, it was a minute ago. So the latest image for our Flask application has been pushed over here. Now, so that's how you can push it over Docker Hub. Now let's look at how we can run Docker in our local. So before moving on to that, I want to understand if everyone has this clear, or if anyone has any questions. Please zoom the Docker Hub screen. Okay. Yeah, Dockerfile doesn't have any extension. So it depends on the kind of CI files you are using. So if you're using like a CI file called Travis, then you would have to put the instructions. And for GitHub Actions, it's just automatic. Okay, so I think most folks have understood. Let me just share my screen again. Is my screen clear? Is my screen visible to everyone? Okay, it's visible. If people want me to zoom in, let me just zoom in. So right now I'm in my home directory. Let me just move to my desktop. And after moving to desktop, let me move into the scalar practice demo app. And after moving into the scalar practice demo app, let me just build my Docker file. So for building the Docker file, I have already written the commands because I don't remember the exact commands. So what I do is, so in this directory, if I do an ls, you can see all the files that are there. So we have our Docker file, and now we are going to build this Docker image. So for that, I run this command docker build -t demo app latest. So demo app will be the name of the image, and latest is the tag, and dot says that my Docker file is in this directory. Now I build this, and okay, so my Docker is not running. I need to run Docker. Start Docker. Give me a second. So you can see over here, it says Docker desktop is starting. It will take just a minute to get started. Yeah, so you can see that Docker has started right now. And now let me build my Docker image. And so this is going to be very similar to what you saw in the pipeline. So the build has completed right now. We have built our Docker image. Now the next step that we want to do is we want to run our Docker image. But before running, let's do one thing. Let's go to localhost 5000 and see what's there. So nothing is there on localhost 5000. So what I'm going to do right now is I'm going to run this command. So what this command basically says is run the demo app on the Docker's port, which is 5000, and map the port of the application to 5000. So Flask is running by default on 5000. So this command is telling that map that port to the Docker's 5000 port. So let's go ahead and run this. As soon as I run this, you can see something. Yeah, you can see that the Docker image is a Docker container is live, and we have hello world here, which is our Flask application. Now let me show you something else as well. Let's go to, let's say, localhost 3000. So this site cannot be reached. So now what I do is I have a Docker image with me, and now I'm saying that map the original port 5000 to the port 3000 of Docker. So now what it does is it maps it to 3000, and now let's do this. You can see that it's running on port 3000 as well as port 5000. So we have two Docker containers running of the same Docker image. And now I also installed Docker UI because it's very handy, and I installed it from the official documentation. So if I open Docker's UI, you can see that these two apps are running. So I can go into this app, and when I go into this app, you can see the logs over here. And this log is showing that, a Flask application is running, and this is actually the IP address of the Docker image. And similarly for this as well, you can see that it's running on port 5000. I'm just going to close it for now. I have removed the container. Now let's do something. So remember how we had pushed our image onto Docker Hub? So now what we are going to do is we are going to pull our image from Docker Hub and run that image. So we are going to pull the latest image from Docker Hub. So what all of you can do later on is you have this repository. You can just pull this Docker image from my repository, and you will also have a Hello World app running in your local. So let me just again copy the command for pulling. So what this does is, again, it says, okay, I think I copied the wrong command. Just a second. Okay. Uh, so it says that pull this image from Docker Hub and map it to port 8000. And the name of my repository is a-square14/demo app. And that is because on Docker Hub, I have named it as this. So now let's first go to 8000 and check nothing is on 8000. So there's nothing here. Now let me pull this and you can see it in action. What is the problem? Okay, just give me a moment. I think I have written the docker pull command wrong. So let's look at this. It just says docker pull. So I can just do docker pull a-square14 demo app. It uses the latest default tag. Okay, and it has pulled this thing. So now if we go to our Docker UI and we see, one second. It has downloaded the latest image. Now we basically need to run that image. So what we are going to do is, we are going to do this, and we are going to do a latest over here. So now you can see that it is running the latest image, which it has pulled from Docker Hub. And when we do localhost 5000, you can see that the Hello World program is now running. So that's about how we pull from Docker Hub and we push images to Docker Hub. So that's it for Docker for today. I'm going to stop here again and see if folks have any questions. I'm going to stop my sharing screen. So someone has asked hello world and something. So I'm using a different repository for today. I think you were looking at a different repo yesterday. How did you push the image into Docker Hub? just write code and you push it, and then your CI pipeline runs, and if everything looks good, it gets deployed to production. But in delivery, there is a manual step before it is released to production. So most of the companies use continuous delivery because the production environment is like it has a lot of stake involved. So for example, take facebook.com, like before releasing it on a production environment, some folks would still want to do a manual check to see if everything is okay. So most of the organizations use continuous delivery. So this diagram over here, it shows the steps of CI and CD. So you build your project, which we did using our requirements.txt file. Then you test it, which we saw yesterday. We wrote a simple unit test and we ran it. And then after the testing, we deploy it on staging, and then we deploy it to production, and then we have monitoring. So we are going to see what monitoring is today, and we are going to see continuous deployment as well. So after continuous deployment, today we are going to do continuous deployment using Heroku. So let's understand what Heroku is. So Heroku is basically a platform as a service, and it runs apps in smart containers. So what is a platform in a service? So basically in Heroku, we don't have to worry about infrastructure, and it runs our application in dynos. Dynos are fully managed runtime environments, and we don't have to care about anything. We can just deploy our application on Heroku, and it will take care of a lot of infrastructure stuff on their own. It's really good for hosting personal projects or small projects, and even a lot of large organizations use it. So next we're going to go through a demo of Heroku, but before that, I'm going to stop sharing my screen and see if folks have any questions. So I have informed what is the difference between testing and staging. So there are a lot of platforms in which you can deploy your application. You can deploy it on AWS, you can deploy it on Heroku. AWS is more extensive, it gives you more features, but Heroku is somewhat similar to AWS, but not exactly. Like both of them have a few common features, but they also have different features. And can we use Windows instead of Ubuntu? Yeah, you can definitely use any operating system that you want. And Aman has asked, what does Dino mean? So let me just tell you what dynos are again. So they are the building blocks of Heroku. You can think of it in that way. They are just like lightweight, isolated environments that provide you with compute, memory, an operating system, and a file system. So this is what, like, they are also containers, and the Heroku platform uses the container model to run and scale these Heroku apps. So the containers that Heroku uses are called dynos, and they are isolated virtualized Linux containers. So, your app, when it's very small, it can have less dynos. And if you get more traffic, you can automatically configure it so that you use more and more dynos. So that's what dynos are. And then someone asked if someone can share the link to the heroku.com. So let me just... How to make repo in Docker Hub. You can click on the new button and make repo. So how would environment specific variables parameters be included in the Docker image? So for that, you have to go into the actions tab and then add those environments in your CI config. I had shown the demo over there. Okay, so I think we are good, and now we are going to go ahead and show, if not show, because we can just go through the Heroku platform. So is my screen visible? So let's go on Heroku. Is my screen visible to everyone? Okay, great. So let's go on Heroku and let's see what to do over here. So I have already, like before, I have already created a Heroku app, but let me just show you nevertheless what happens. So I click on create a new app, and over here I can just leave the app name blank, and I can choose a region, and then I can just create an application. So after I create an application, it's going to look something like this. And in this application, what I have done is so after the application is created, you will get this screen over here. And over here, you can see that there is the same screen. Just in this screen, I have connected my GitHub. So my GitHub has already been connected. When you click on this button, it's going to prompt you to log in and type in your password, just like OAuth. And then you can just connect your GitHub. Then you need to connect your repository. So if you go over here and you choose, after connecting GitHub, you will get this option of choosing a repository. So I have connected this over here, and then I have automatic deploys enabled. So what does this mean? Over here it says that anything that is pushed to my main branch, it will get deployed over here. And I have also checked this box which says wait for CI to pass. So what this means is only if my CI pipeline passes, then it is going to get deployed, and this is the branch that I want to deploy, which is the main branch. So this is the part about linking the GitHub, but we also need to do some changes in our GitHub. So on GitHub, for Heroku, we need to create a proc file. Now let me tell you what a proc file basically is. So a proc file is basically a file which will tell Heroku how to run this app. So in this proc file, you can see that it says our Flask app is app.py, and it says to run the Flask app on the host of the dyno and using the default port. So let's do something. So now over here, you can see that this is a branch main, and we want to deploy this branch. Let me just deploy it. So it is building this branch. And over here, you can see that it has detected a Python app, and then it is installing the requirements with pip. And it says that the proc file declares types web, which is what we had declared. And it has deployed it, and your app was successfully deployed. So if I type view, you can see that this application has been deployed. It's Hello Scalar, and this link can actually be accessed by anyone. So let me just share this link here. Zoom, please. Okay, let me just zoom it. So if you can see, that link was deployed. So now let me go to my main again, and let's see this app.py. So this app.py basically said hello scalar, and that's what this link is doing. If you see this link, oh sorry, I think I closed that tab. Okay. So yeah, it says hello scalar. Now this link also has hello scalar in it. Now what we are going to do is we are going to make a change here and we are going to see it in action. So let me do, I will also have to change my test for this. So now I expect my CI pipeline to fail because the test here expects a hello world. But let me do let me commit the changes. And as you can see, the before one had failed because the tests were not matching. Now let's go to Heroku. And before, like instead of waiting for the CI pipeline, let me deploy this branch again. So it is deploying. And now if we check our app, it's going to say, hello everyone, thank you for joining. The same link, if I refresh, it is changing. So this is how continuous deployment works. And you have just seen it in action. And I'm going to stop here. I'm going to look at questions for the next 5 minutes. And after that, I'm going to hand it over to Dev. So let me see questions for how does the pipeline know which tests to run? So I had shown this yesterday. I have mentioned in the pipeline which folder has the tests and how to run the tests. Yeah, I understand it might all sound a bit difficult if you haven't attended yesterday's session. Before we move ahead, I have some quizzes. Let me just share those quizzes with everyone. So this is the quiz. And the next quiz that I have. Okay, so the next quiz that I have, we are going to do it later on. So now we are going to talk about some advanced topics. Let me just share my screen. Is my screen visible to everyone? Okay, great. So let's move on to the next topic, which is configuration management. So till now, you saw that we can deploy it on Heroku. And while Heroku is well engineered for deploying certain types of applications, it can be tricky to deploy highly customized configurations. And also when you want like more control over your environment, it can be a bit difficult because then you have to look at Heroku plugins and Heroku integrations and also do things a certain way. So Heroku basically limits your ability to customize. Uh, Somewhat, like for most applications it should be fine, but really large companies and startups, they prefer hosting their own servers and hosting their own applications. So we are going to talk about configuration management and what where it comes into use. So the short thing is that when you have an installation where you don't want to customize much and you don't need a lot of servers, Heroku is great. When you want full control over your infrastructure and you want full security over your infrastructure, you can host your own servers, and that's where configuration management comes into play. So, what is configuration management? So, configuration management is basically the management of your software on your hardware. And what does this mean? So, what configuration management does, it basically maintains the consistency of your product based on its requirements. It designs its physical and functional attributes. So, how does configuration management maintain the consistency? So it does so because it is applied over the entire life cycle of your system, and that's why it provides you with very good visibility and control. And it also means that you can continuously check and monitor the performance of all your servers. So we are going to look at another example of why we need configuration management. So before we dive into more detail, let's see what are some of the problems that were there before configuration management was used. So before configuration management was used, managing multiple servers was a huge problem. So what would happen is that every server had to be managed manually. So the system admin would log into a server, make changes, then log out, then log into a different one, and then make changes. And they would have to make sure that each server had the consistent same computing environment. And this is okay when you have 2 or 3 servers, but when you have hundreds of servers, it would become very cumbersome and it would take a lot of time. So another thing is that if there was a faulty server, then it would take even more time to repair it. You would have to go and check on every server. And now when configuration management came into picture, what it does is it divides all the systems in any infrastructure according to their dedicated tasks, and it organizes the system in an efficient way. So this is called baselining, and if you can see on the diagram, in the below the line on the right hand side, there are web servers, database servers, app servers grouped. This is what is baselining. And what basically in configuration management people do is you write a script, and I write a script for web servers, and then I run the script on just each machine, and that single script is going to install all the dependencies and configure everything that I need for the web servers. So let's say I need to install some software, so it gets installed on all the servers equally, and it's also easier to monitor because I can have scripts running in all the servers and it can tell me what's going wrong with which server. And this is the first problem. The next problem that configuration management solved was scaling. So earlier scaling was manual. So let's say you are an e-commerce site and you have Black Friday sale coming up, and you know that your e-commerce site is going to see a huge rise in traffic during the Black Friday sale, and you need more load balancers and servers during this time. So earlier what you would do is you would have people go in and assign more servers, configure more load balancers, make sure everything is okay, and after you get the necessary hardware you would have to like provision them properly manually. With configuration management you can write scripts. You can write a script saying if the traffic goes above this point, scale up to this much extent, and then use this load balancer. So basically you write one script and that does everything. Yeah, it sounds pretty magical, but it's really a great thing, I think. And also, like, scaling up is something we talk about, but scaling down is also very important, because if you're going to use so many servers and most of them are not in use, it's going to be very expensive for your organization. So you need to scale down, and scaling down is very easy. In the same script, you can write that after the Black Friday sale is over, or after the traffic is below this point, you can scale down. So this is the second problem that it solved. So let me again tell you the first and second problem in one word. First was managing multiple servers, and the second was scaling. So the third problem that configuration management solved was increasing the velocity of work. So this is pretty obvious, because a lot of manual work was removed. So it definitely increased the work velocity. And the fourth problem that it solved was rolling back. So, what exactly is rolling back? So, let's say again you are an e commerce site and you want to add a new feature to your product. And you add a new feature, you change the config for various servers manually, and then it's rolled out to users. And now let's say your users have started giving you really bad feedback and they do not want this feature at all. What you would have to earlier do is roll back all the changes manually that you had seen. You would have to remove those changes from your servers, and you would have to like uh, get the old configuration and write that down. But in configuration management, the older version will already be documented. You will have the script, it will also be documented in your pipeline. So you can easily do this. You can run a script which says that remove all these configurations and run the old configuration, and that feature will be gone, and you will have the old stage of your code. So the four problems, like I mentioned, that config management solves are managing multiple servers, scaling, increasing the work velocity, and rolling back. So now let's look at some tools for configuration management. The most commonly used are Ansible, Chef, and Puppet. And today we are going to talk about Ansible, and we are going to see a small demo of how to use Ansible. So before we go into that, I would like to see if folks have any questions. Okay, so I don't see a lot of questions, so I'm going to assume everything's okay. And let's move on. So why do we need configuration management if we are using containers? So you would need to deploy your container somewhere. And like I said, you can have multiple containers in a virtual machine, but you would need some configuration for that virtual machine as well. So for that, you can use configuration management. Okay, cool. So I'm going to assume everyone has understood everything, and I'm going to move on to the next part, which is Ansible. So what is Ansible? So Ansible is a push-based configuration management tool. And what do you mean? What do I mean by push-based configuration management tool? So there are two types of configuration management tools. One is push-based and the one is pull-based. So what a push-based tool does is we write a script, and then whenever something changes, Ansible pushes these changes onto the servers. And in a pull based thing, the server is continuously going to ping our tool, and then it is going to pull in all the changes. So that is one thing. And then Ansible automates the entire IT infrastructure, from your servers to your deployment to your monitoring. It is simple, agentless, efficient, and powerful. So what I mean by agentless is that it does not have any agents. So you do not have a third party or any third party service or any service, not even third party, between Ansible and your servers. You write Ansible files and you can locally run them. You can run them locally or on your servers directly. And repetitive tasks are reduced. Like mentioned earlier, it removes manual and repetitive tasks. And you can configure, install, and deploy steps in a single file, and you can reuse the same file. And it is also less error prone. So before we get started with Ansible and some terminology and writing a simple Ansible playbook, I'm going to have a quiz here. Okay, so the quiz is over, and let's move back to the presentation. I just want to confirm, can everyone still see my screen? Great. So let's go into some terminology before we start writing our Ansible playbook. So three things that are very important. First is modules. So modules are small programs that do the actual work, and we are going to divide our Ansible file into modules. And then these are the modules that get pushed to the target server, and then they do their work, and then they get removed. And then what are playbooks? So a playbook is a file in which multiple modules are grouped in tasks, and these modules get executed with arguments. They have a description. And what this playbook does is it tells that how, in which order, at what time the modules should be executed. So playbooks have uh, modules grouped into tasks. And then we also have an inventory list, which is basically a list of all the machines involved and all the IP addresses that are involved. Now, next we're going to see how to write a simple Ansible playbook. Let me just stop sharing the slides and start sharing my screen. Is my screen visible? Okay, great. So let me just go to the Ansible file that I have written beforehand, and just before that, let me go to the correct directory. Okay, so if you can see that I have written this Ansible file over here, and what I'm going to do is I'm not going to deploy it on a remote server. I'm going to deploy it on my local host. So my local host is going to be the server, and you can see how I'm going to do that. So I named this playbook as playing with Ansible, and I define my host as localhost, and I say that we need a local connection. And then I define some tasks. So I define the first task as just execute a ls minus lrt command, and then in shell it executes this command. So what this basically does is this command is a Linux command which will show me what all files are present. Let me just write a debug line after this so that I can see the output of this command. And after that, I install pip. So this is going to look very similar to the workflows file. And on my shell, I install pip, and then I register the output on this variable, and then I print this variable, and then I install Flask, and I install the dependencies from the requirements.txt file, and I register the value here, and I do this. And then I run my Flask application and register my value. So this is a very simple Ansible file, and I'm going to run this and show it to you. So it's very simple to run. I just do Ansible flask.yml, and I think I got the command. Yes. So it is Ansible playbook flash.yml. So it is running the playbook, and I'm going to show you step by step what exactly happens. Okay, so it's giving an error, and I know why it is giving that error. I'm going to explain it to you in a moment. It is giving the error that the local host is already in use. So our Docker container is running on port 5000. That's why it's not able to use this. Let me just delete this, and now my port is free. If I run this again, it should work. So my Flask application is running. Let me just show you from the beginning. So what it does is it says no inventory was parsed, only implicit local.
Can you zoom in? Just
Yeah,
check
yeah,
your
yeah,
request
sure.
for people asking.
Is it better now?
Yep.
Wait,
Guys,
let
this
me.
is better. Looks good to me. Yeah. All right. Yeah.
Do folks want me to repeat anything they might have missed due to the zooming out?
Yes. One person says yes. Guys, do you want anybody to? Yes. Okay. I think you should repeat a bit.
Okay.
Maybe quickly
Let
repeat.
me let me just repeat the Ansible file as well. I think I should have zoomed it beforehand. So this is a simple Ansible file, and let me just close this again. I'm going to show it quickly. So this is a simple Ansible file in which the name of the file is playing with Ansible, and over here I have identified the host as localhost and connection as local, which means Ansible is going to deploy it on my local server. We can in fact have a server on DigitalOcean or AWS and run this Ansible file to deploy it over there. Then I have defined some tasks. The first task over here is run the command ls-lrt. What this does is it shows me in this directory what all files are there. The second task is installing pip, which is a tool for Python. And then again, this debug line shows me the output of this command. Then the next step, I install Flask, and I do that by using the requirements.txt file. And then I see the output, and then I run the Flask application. So this is what the Ansible file does, the Ansible playbook does. And now let me run it. So for running it, it's a very simple command. You just type Ansible playbook and then the name of your file. Okay, so now let's see this. So it starts the playbook playing with Ansible, and then it starts the task, and then it says, okay, it's localhost, and then it goes to the first task, and it says, just execute a ls lrt command, and this is the output of the command. So you can see that ls lrt shows me all the details, and these are the files that are in my directory, and these are the permissions for it, read, write, and who owns the files and the date and the time. And then it installs pip. It says requirement already satisfied, which means that my pip is already installed on my local, so it doesn't install it again. It installs Flask, and it says requirements already satisfied, which means requirements are satisfied, and then it runs the Flask application. So now if I go to localhost 5000 and I refresh it, you should see a hello world over here, which shows that my Ansible playbook is running. And now if I close it says the site cannot be reached. So this is writing a simple Ansible playbook and running it. And if you want to run it on a different server, all you need to do is have a hosts.conf file, and in that file you can specify the IP address of the servers that you want to run on, and it's going to run on that. So before we move on to continuous monitoring, I'm going to stop here and take some questions and also have a small quiz for you. So are there any questions? So there's a question, how did you configure Ansible or installed it? So that's a good question. I think I missed saying that. So for configuring and installing Ansible, you can go to the official website of Ansible, and there is the guide. Let me just paste it on chat, and there's a simple command for it. How is Ansible used for scaling? So on Ansible, you can mention if you want to have more servers or more containers, and it's going to do that. Okay, so um, I think the question, I have taken some questions. Let me launch a quiz. Um, okay, so I am going to launch a quiz. Okay, great. I think the quiz is over, and now I'm going to move on to the last portion of our workshop, which is continuous monitoring. Let me share my screen. So now we are going to move into continuous monitoring, and let's understand why we need continuous monitoring before we move into anything else. So let's say you have a CI/CD pipeline that has automated everything, and everything is super fast right now. And we have deployed our application, we have written playbooks to automate a lot of things. Now you need to figure out like which portions of your infrastructure are causing problems, which part is slow, which part is causing the request to take more time. So one way to do that would be a person sitting at his computer, his or her computer, and looking at the logs and figuring out, okay, this went down right now or that went down right now. So that is manual monitoring, and it slows down the entire pipeline and makes everything we did till now redundant. So it's very important to have continuous monitoring. And what continuous monitoring basically does is that it rapidly gives you information about performance errors and problems. It can tell you the root cause analysis and new endpoints which can cause issues. So let me give you an example. Suppose we have deployed an application and we are using an application performance monitoring. We will instantly find the issue, and we can instantly fix it. If we do not have continuous monitoring, we would have to find the issue manually, and then we would have to tell the developer to fix it. And what you would like, it would be a manual process all over again. So now what you do is you run the performance monitoring tool, and typically what happens is before you release to production, you deploy your server to staging and you run and monitor it for some time, like let's say for half an hour. Some people do it for a day. So you monitor it for some time, and then you can see all the metrics that all the requests are taking the correct amount of time, nothing is going down, all the servers are in good health. And then you can confidently say that this is going to work perfectly on production, and you can promote it to production. This ensures that server health is not compromised at any time. So a lot of servers also have backup servers, and in monitoring what you can do is you can monitor your main server, and as soon as there is a problem in the main server, you can switch over to the backup server while the engineer figures out what went wrong with the server that had the problem. So in the next slide, we are going to see what exactly is continuous monitoring. So continuous monitoring is an effective system where the whole infra is monitored in an ongoing and automated fashion. So On the right hand side, there is this diagram, which is a standard by NIST, which is the National Institute of Standards and Technology in the US. So it has a few steps, and I'm going to walk you through the steps. I'm just going to take a break of 1 minute to drink some water. So, okay, so I'm back. So let's look at the diagram. And in this diagram, basically, we have some steps. And the first step is defining the strategy. The second step is establishing the architect. The third is implement and collect. Then analyze and report, respond to findings, and review and update. So what happens in the define strategy stage, which is the first stage? So in this, we develop a monitoring strategy and we figure out the steps that we need for monitoring our system. This is very similar to figuring out gathering the requirements and figuring out the design in a SDLC lifecycle, sort of similar to that, but not exactly. And then we establish the architect. So what do we mean by establishing the architect? We establish the metrics and the frequencies. So metrics are basically like, let's say I have a server and I want to say that this server is good if it is constantly up for 2 hours, or if I want to say this server is good if it can handle X amount of requests per second. So those are some metrics that I use to identify my server's health. So we establish these metrics, that these are the things that we are going to use. Then we also see the frequencies. So at what time, what is the frequency at which we are going to monitor our system. And then the third step is implement and collect. So implement and collect, over here it means that we are going to implement our plan and collect the data, and then we go on to the next step. After collecting the data, we are going to analyze the data and report our findings. So we are going to analyze the data, and if there is some problem, we are going to report that okay, there is a problem. We are going to send pings to engineers, and then these people are going to respond to the findings. They are going to figure out what went wrong or how they can improve the system. And the last step is review and update. So review and update is also called post-mortem in many organizations. Over here, what they do is, if there was an incident or if there was a finding in which something went wrong, they are going to review it and write a document and update it, so that the same thing does not happen again. So now I'm going to talk about a very common and popular tool called ELK, which is Elasticsearch, Logstash, and Kibana. And this is a stack which is commonly used for continuous monitoring. So first, let me explain the diagram to you, and then I'm going to dive into these in more detail. So we have, on the right hand side, you can see we have microservices, and we have microservice 1, microservice 2, and microservice 3. So what these microservices do, they generate logs. And how do they generate logs? So we can configure Logstash, which is a logging tool, and we can configure it for our Flask application. And then when we are running these microservices, they are constantly writing these logs, and Logstash is reading these logs and indexing it to Elasticsearch. So what does indexing it to Elasticsearch mean? So it means that Logstash will collect the logs, transform it to JSON messages, and feed it into Elasticsearch. So Elasticsearch can be thought of as a document storage platform. It is not a database, it is a document storage, and it stores the logs for the time being. And then Kibana provides a UI for Elastic. So what Kibana will do is, Kibana is going to allow you to query the data which has been logged in your Elasticsearch, and you can use Kibana to see visualizations and to see your data. So let me explain this to you on more detail. So Elasticsearch is basically built on Apache Lucene library, which makes it much faster than the traditional SQL, and it is very flexible. schema flexible REST and JSON based distributed search engine. And it provides the ability to search, analyze, as well as store large amounts of data. And it also provides flexibility and scalability. And like I mentioned before, Logstash is used for centralized logging as well as parsing. And it is an extract, transfer, and load tool that modifies and parses and stores logs with Elasticsearch. So Logstash can collect data from multiple systems into a central system. Like you saw in the diagram, it's collecting from multiple microservices and storing it in Elasticsearch. And lastly, Kibana is a web-based tool through which Elasticsearch databases visualize and analyze stored data. Kibana offers powerful and easy to use features like histograms, line charts, pie charts, heat maps, etc. So I'm going to this is a demo, this is a like demo picture of how the Kibana dashboard is going to look like for sample e-commerce site. So if you can see on the left hand side, there is the description, and on the right hand and just below it there are graphs. So these graphs are saying a percentage of the target revenue, so how much revenue they have earned up to those dates. And on just below it you can see the transactions per day. So all this we are logging all this into Elasticsearch, and then Kibana is allowing us to visualize it and get the data. And on the right hand side you can see the median spending, what each customer is spending on this site, what is the average amount of items sold, what is the products per day sold, and the sum of the revenue. So that's about Elasticsearch, Logstash, and Kibana. And I'm not going to give a demo today of this uh, because it's pretty like heavy and my laptop crashes a lot. But I can just walk you through the official documentation of this. But before doing that, let me just stop sharing and have a quiz for all of you. Okay, so are there any questions? Okay, so I don't see any as such
There,
specific questions.
there are a few questions in the chat if you can take them up for a minute.
Okay, yeah, sure. Can you help me figure out, like, because
Uh,
there are so many messages
Somebody
coming
asked
in.
earlier, this is Kibana doesn't look like. And then somebody answered that this was a Kibana custom dashboard.
Yeah.
Yeah, maybe you can shed some light on that.
Yeah, so it is a custom Kibana dashboard. So there are a lot of ways in which Kibana dashboards look. So Kibana dashboards have pie charts, Kibana dashboards have bar charts, they have histograms. So I just picked up a simple e-commerce image dashboard for Kibana so that it's easy to understand for everyone.
Right. Other than that, I don't see anything specific. Um, I think we can
So
you can continue and maybe you can take questions at the end.
yeah, I'm almost done with the content, but let me just share my screen again. Is my screen visible?
Not yet. Yeah, now it is.
Now, okay. So let's just go to the official documentation of Logstash, Kibana, and Elastic and figure out what's happening. So to configure Logstash, you can download Logstash by just saying install Logstash and then, sorry, it says Windows, but you can go to the official Elastic site and it's going to show you how to install Logstash, and there are multiple ways of installing it. I suggest the downloading it from the binary, and then after you have downloaded it, you just need to go into that directory and start Logstash. So for Logstash, you need to write a simple configuration file, and that configuration file is going to tell you the mechanism in which you need to log. So over here they have shown a simple config file and used it to run Logstash. So create a simple logstash simple.conf and save it in the same directory. Then over here you can see that it's taking the input from std in and it's giving the output to the Elasticsearch host. And this Elasticsearch is running on localhost 9200. So before Logstash, you need to download Elasticsearch and start your server, Elasticsearch server, which will run on 9200. And then you need to run this Logstash file where it's going to uh, output all these things to Elasticsearch. And for installing, for Elasticsearch, you can go to the official website of Elasticsearch, and there are a lot of things over here. So let's go to this ELK stack over here. So you can see this download and get started portion, and then when you go over here, you can see that they have get Elasticsearch, get Kibana, and you just need to launch it like this, and then you need to activate the features. So that's it for Logstash and this thing. And for Kibana, it is your window into the Elastic Stack, and these are various views of Kibana. And after you have downloaded Kibana, you can see all these different types of charts. You can query it. You can also write queries to get more data from your systems, and you can build simple visualizations, and you can see lots of different sort of visualizations, heat maps, etc. So a really good use of Kibana is to figure out like what in a business world scenario, what portions do you need to optimize? What are some things that you would like to focus on? So with that, we are at the end of the Devops Bootcamp content. And if there are any questions, I'm happy to take them. And yeah, I'm going to modify the GitHub repo in some time, and you can just check the repo again. And for the slides, I think Scalar will be able to answer more if that's. How would an architecture for monitoring look like when I am monitoring services from different clouds? So you would have your monitoring set up on a different server, and you would configure it so that it reads it from different cloud providers by providing their IP addresses. What is the duration of days or months to save logs in Elasticsearch? You can configure this. You didn't show deploying to staging and prod. So deploying is pretty much same. You just define a server as staging and a server as prod, and you define to both of them. I mean, you can define to either one or both of them. It's not different. How can we alert if it reaches to threshold? So yeah, there is something called alerting in monitoring, in which you can configure things. You can configure your alerting so that if something reaches below a particular threshold, alert people. So there is an app called PagerDuty that is generally used. So we often get pings on PagerDuty that your infra is down or something needs uh, to be fixed.
Guys, uh, thank you, Atibhi, first for the session. You can keep answering the questions. Guys, we'll also be launching the polls in the chat so that we can get feedback and work accordingly. It's important for Atibhi and us both. Uh, so, just your overall experience of the masterclass of the boot camp, and uh, 3 to 4 polls will be launched. I request all of you who are attending to launch just as the feedback, uh, how you felt. It will mean a lot to all of us. Please go on, Atibhi.
Okay, I'm just looking at some of the questions. Um, I'm a Java developer and want to move as a DevOps engineer. How can I get it? So I think you can start with any good DevOps course or book online and start doing it. You can also try working on a small project of your own so that you have a good hang of everything that's used. So, what is the use of Kubernetes? I think this question I got a lot about Kubernetes. So, when you have lots of Docker containers to manage them, you use Kubernetes. Kubernetes is a tool that allows you to manage your Docker containers, and yeah, so that's what Kubernetes is. I did not cover it because it's a very vast topic, and that Kubernetes itself would take like 2 hours. So, but in simple words, that's what Kubernetes is. You can go to Cloud Native Computing Foundation's website. They have really amazing stuff on Kubernetes, and you can learn over there. Am I allowed to share the PPT, Devrup? I'm not sure.
Yes, you can share it, Atibhi. You can share it on Discord as well. I had shared
Okay.
it on Discord link earlier. You can share it here as well. Not everybody will be able to.
Yeah, yeah. I'll just share the link over here as well.
I think this is the last poll. You can still go ahead and take any question.
Yeah, I have around some time remaining. So I'm just looking. Please tell regarding job.
A few people have had questions about DevOps careers and all of that as well.
DevOps for?
Careers in DevOps and all of that is what I saw.
Okay. So how can we be a teacher on Scalar? Devrup, do you want to take that?
You can send us. We are always looking for remote instructors. Actually, that's actually one thing. Uh, we are looking at instructors. We are looking at mentors. We are constantly like we have grown from I think 150 odd people to 1,000 people in 1.5 years or so. So obviously we are always looking for more people to join us. So just drop a mail to any of our HR folks. We drop a mail to support at scalar.com if you like. We're always open. All of us answer emails. My email ID is devroop at scalar.com.
And I think like Shailesh Singh has written, "Hey, Scalar doubt cleaning expert here." I really want to thank him because he answered a lot of questions today in the chat. So really a shout out to him for answering.
Thanks, Alice.
And and then someone has written like actually this person has asked this question like I think 10 times. You are a software developer and you are teaching DevOps. Should we learn both? So it's not necessary to learn both. It just depends on your interest. So even though my normal day-to-day work doesn't involve a lot of DevOps, I'm really interested, and I had the opportunity to learn this in college through a course, so I learned it.
How many want Atibhi to come back for another time on a different topic?
So DevOps is a full-time job for a lot of site reliability engineers and DevOps engineers, and it's a pretty amazing growing field. So definitely people can look into a career into that.
All right.
Yeah.
There's no certificate for this. Just clarifying. There's no certificate for this session. Uh, there's uh, there's an so just an exclusive thing for everybody who are registered and is attending the session right now. The first 50 people who click on this link that Jatin has posted will be able to connect with our alumni who work at these good product companies, and you can have a one-on-one sessions with them. This interactive sessions with them. You need to fill this form that Jatin has put. This is a surprise, so to say, that we kept for the end. And the winner of the quizzes will be communicated via email. Vamshi, I think Atibhi can share all the notes and PPT on
I
Discord.
have shared the slide over here. I'm going to update the GitHub repo and share that on Discord in a while. Did landing a position in Twitter require a lot of DSA? Did DevOps help in any way? So it required a lot of DSA because interviews were DSA based, and DevOps did not really help directly. But in my managerial interviews, they asked me, and it was a pretty engaging discussion to talk about DevOps.
Jatin, can you pin the PPT and the notes, of course, and the GitHub link? Yeah.
So my role is fully development. I do very little of DevOps in my day-to-day work, but it's something I'm really passionate about and hope to do more. If first heavy coding not required. Okay. So someone is asking, ma'am, what is the exact difference between SDLC model like waterfall model, agile and DevOps? So I had actually covered this in a lot of detail yesterday, Sudhir. And if you look at the PPT and you look at the scalar, like speaker notes, I've written it in pretty detail over there. So I think you can figure it out from there.
All right. Guys, one more thing, just a heads up, we'll also be coming up with a DSA bootcamp soon for the community. Keep an eye. We should be able to put it out soon. So thank you, Atibhi. Thank you so much for taking the
Yeah.
session. If there are
Thank you,
more
Devrup. And
questions,
thank you everyone for joining.
if there are more
Okay.
questions, feel free to join on Discord. And we have a bunch of experts there as well. I think that Atibhi can also join in sometime
Yeah,
answering
I'm
questions.
already there on the Scalar Discord.
Yeah, so you can use the
Yeah.
Learn Together channel maybe there.
Okay.
And thank you, Atibhi. Thank you so much again.
Yeah, thank you everyone. Thanks. Bye.
Thanks, guys.